In this video, we will go through some examples of the power rule, sum and difference rule, and the constant multiple rule. You will recall from the video introducing these rules that they are as follows. Let's start with an example problem for the constant rule. Find the derivative of f of x equals 5,000. As stated, the derivative of any constant is 0, so f prime of x is equal to 0. Next, let's look at another example. Find the derivative of f of x equals x to the 1/4. What rule do we use to take the derivative of this?
There is an exponent on x, so I think we use the power rule.
That's correct. Take the exponent, multiply it by the coefficient, or the number in front of the x, and decrease the exponent by 1. We get f prime of x equals 1/4 times x to the negative 3/4.
If we take the derivative of the answer we just got, would we need to use other rules?
Yes, to take the derivative of this new function, you would also need to implement the constant multiple rule. So the function will be written as f of x equals 1/4 times x to the negative 3/4. To write this in the form of the constant multiple rule, we must replace c with 1/4 and f of x with x to the negative 3/4, writing f prime of x is equal to 1/4 times d over dx, x to the negative 3/4. Now we need to use the power rule to evaluate the function x to the negative 3/4. The derivative of x to the negative 3/4 is negative 3/4 times x to the negative 7/4. Substituting that into our original function, we get f prime of x equals 1/4 times negative 3/4 x to the negative 7/4. Simplifying the expression, we get f prime of x equals negative 3/16 times x to the negative 7/4.
Will we often need to combine rules like this?
Yes, in most cases, you will need most, if not all, of these rules, but once you have done enough examples, you will follow these rules without actively thinking through them. Let's look at an example of the sum and difference rule combined with the constant rule and power rule. Find the derivative of f of x equals x cubed plus x minus 18. First, we'll apply the sum and difference rule to get that the derivative of the function is d dx x cubed plus d dx x minus d dx 18. Now we can take the derivative of each term separately and add or subtract them appropriately to get our final answer. First, we can take the derivative of the first term, d dx x cubed, which we can differentiate using the power rule. This is equal to 3x squared. Next, we will take the derivative of the second term, d dx x, which we can differentiate using the power rule. Doing this, we find that it is equal to 1. Finally, we will take the derivative of the third term, d dx 18, which we can differentiate using the constant rule, which tells us that this is equal to 0. Combining these terms correctly, we get our answer as f prime of x is equal to 3x squared plus 1. Let's take a look at a more complex example. We are given the function f of x equals 3.7x squared minus 5.1x plus 27 and asked to find the first derivative. Just like the last example, we first need to use the sum and difference rule. Doing this, we get that the derivative of the function is equal to d dx 3.7 times x squared minus d dx 5.1x plus d dx 27. The first term is 3.7x squared, which we can differentiate using the constant multiple rule and the power rule. Doing this, we get 7.4x. The second term is d dx 5.1x, which we can differentiate using the constant multiple rule and the power rule. Doing this, we get that the derivative is equal to 5.1. The third term is d dx 27, which we can differentiate using the constant rule, so we know that it is equal to 0. Combining these derivatives properly, our answer is f prime of x equals 7.4x minus 5.1. Now let's say we are asked to find the first derivative at x equals 8.5. How do we determine the answer f prime of 8.5?
We substitute 8.5 for x to find the derivative at that value, which equals 57.8.
Exactly.